Good morning, everyone. Today we're finishing up Unit 2 with 2.09 through 2.11. So last week we ended with solving logarithms, so that's what we're going to start this week out with. And then we're going to focus on how we graph them and how do we apply them. So kind of two main topics for today, but we are going to review what we did last week as well. So at the end of this week you have your test, so hopefully after today you'll feel a little more prepared for that exam. Today's essential question, so whether you're in person and I gave you your packet of notes or you're at home, please take a second to copy it down. This is for week 8. And my question is, how does h and k change your logarithm graph? So take a quick minute and copy that down. All right, so we're going to jump in and get started. So this question will be answered a little bit later in today's session. So first we're going to do a little recap from last week. We talked about the difference between exponential form and logarithmic form. So look at my first example with me. If I have 2 to the 4th equals 16, to put it in logarithm form, your base still becomes your base, but when we write it as a log, it becomes the little number. So 2 to the 4th equals 16. 2 to the 4th equals 16. So we take our base and that becomes our little base. Our exponent becomes our answer on the other side, and then the 16 goes next to the log. So I'd like you guys to practice with my second example. Can you please take the exponential form and write it in log form? Okay, so always have your notes handy, even on a test. It's not cheating, it's using your resources. We go to an online school, so the better your notes are, the better you should be doing on your tests and your quizzes. So let's check and see how you did. This one would be log base 2 of 8 equals 3. And for me, just this is personal preference, I have an easier time going from log form backwards to exponential form, so that's how I always double check myself. 2 to the 3rd is 8. 2 to the 3rd is 8. So to me, it's easier for me to look at the log and go backwards. So now I'm going to give you 2 more to practice. Can you guys try the third one down, please? This time I'm giving it to you in logarithmic form, and I want you to write it in exponential form. Okay, do I have a volunteer? Billy?
10 to the 3rd equals 1,000.
Good job. 10 to the 3rd equals 1,000. Now the bottom one, I threw an X at you, and I did this for a reason. So can you guys take the log form and write it as exponential form? And then see if you can answer the question. What would X be? Okay, so Taylor, can you write it in exponential form for me? Okay. Good. So 10 to the x equals 100. And in this case, we can solve that problem, right? We know the answer. My x would be what? Is it 10? 2. 10 squared is 100. 10 times 10 is 100. Okay, good job. So what we're going to do on the next page is we're going to practice quite a few of these. And if you're looking ahead in your notes, I'm going to give you quite a few of these to practice, but I don't write equals x. And there's a reason that I don't write equals x. We're still solving for our unknowns, but instead of me actually writing in equals x, you're going to see what I mean. We're still going to solve them. So I'm going to cover up all the rest. Let's do the first one together, and then you guys can practice the bottom half. Let's try this. If I ask you to solve this, really what I'm saying is, without putting an equals x in there, I want to know what does it equal. So when I write my formula, I'm going to say 2 to the x equals 0.5. Do you guys see how I'm still setting it up in exponential form? There was no x over there, but I know that when they don't give me an x, I'm going to add it in because it's solving for an unknown. But instead of saying 0.5, let's put that as a fraction. So what would my fraction be? 1/2. Everybody okay changing 0.5 to 1/2? So what would my x equal? 2 to the what power gives me a 1/2? Anybody remember? This one we need for today for sure. Good job, Kayla. -1. So let's remind ourselves what happens when I have a negative exponent. So I'm going to come back here for a minute and I'm going to write 2 to the negative 1. When we have negative exponents, where am I supposed to move negative exponents? To the bottom. And then it becomes a positive. So you get the 1/2. Everybody okay with that one? Okay, just a reminder. So let me give you a minute. I would like you guys to work on the remaining 4. Can you guys try those on your paper, please? So write them out and tell me, what is x going to equal? What is that log equal? Okay, so even when I give it to you in this this format, we're still going to write it with a variable in there. So my first one I can write as 10 to the what power equals 10. So Nikki, what did you get for x? X equals 1. Great job. Anybody have a question on the first one? I want to point out something to you. Anytime we see this, what are we going to replace that with? A 1. Always. So when your base matches the number next to it, I can replace that whole thing with a 1. And here's why. Because when I change it back to exponential form, we're really saying 10 to the what power equals 10? 1. So we're going to see this a lot. And the more that you can recognize, hey, when those match, it becomes a 1, it's going to make solving much, much easier for us. Let's try this next one. Let's set up my equation. So 6 to the what power equals 1. Who remembers this type? What kind of an exponent always equals a 1? Now you remember the rule? It's been a while. What do you think? Negative? Nope, negatives become fractions, but good try. Negatives become fractions. What do you think? Good. So Grace says 0. Anything to the 0 power always equals a 1. So my x is going to be a 0. Is that rule sort of coming back to us now? Whenever my exponent is 0, you're always going to get a 1. So let me ask you this. I'm going to do a little side note. Can you use the lines on your notes paper to try this one? What would log base 7 of 1 be? What would log base 21 of the 1 be? What would log base 1,000 of the 1 be? Kayla, what's your answer for all of those?
1.
Not 1. What do you think, Alex? 0. Because in all of these cases, you're really saying 7 to the what power equals 1. 21 to the what power equals 1. 1,000 to the what power equals 1. How do you always get an answer of 1? What does your x have to be? Has to be 0. So your x would be 0. So what I'm trying to get us to recognize is 2 things. First of all was this top one that I circled. When you have a base that matches the number, what's our answer going to be? 1. No matter what our base is, if we have a 1 here, my answer is going to be 0 every time. So can you guys add those to your notes? Those are going to be common ones that we see a lot. So if we can recognize those right off the bat, it's going to make our life much, much easier. Let's try the next one. Ooh, I didn't give you the number there. But last week we talked about how there's really a hidden number there. It's like an automatic. Like a square root's always a 2. If I give you a log and there's no base, what's the base really? Not a 1. 10. Thanks, Jordan. It's really a 10. So logs, I know that there's different rules depending, right? Like if we're talking square roots, it's a square. Logs are always base 10 if I don't tell you. So this one would be 10 to the what power equals 100. So my x would be 2. So do you guys see how all we're practicing on this page is we're taking our logarithm rules and we're rewriting them as exponentials, and then we're able to solve. And then the last one, I need to know 10 to the what power equals negative 100. Who thinks they know what x would be? Tricky, tricky? I did this one on purpose. Anybody think they know? What do you think? You want to guess? Anybody brave today? It's okay to make mistakes in math, right? That's why we're here together. What do you think? Great answer. So what Taylor said is, I don't think you can do that, because if I had a negative exponent, it would become a fraction, like up here at the top. Would you guys agree? Negative exponents become fractions. They don't become negative. So what kind of exponent could I have that would give me a negative? And the answer is, there isn't one. This kind of problem is what we will be calling undefined today. You can't solve it. Not solvable. Last week we talked about how you can't find the log of a negative number. Like your calculator will say error if you tried to do it. So this is why your calculator would say error, because there's not an answer. There isn't one. Positive numbers for exponents will give you big, huge numbers. Negative numbers for exponents will give you fractions. Neither of those are negative. Are you okay with that now that I showed you? Said it was kind of tricky, right? Okay, good job. So we've done a lot of practice now going from exponential notation to log notation to exponent notation. What we're going to practice next is what we ended with last week, which is solving when I have logs in my problems. So here's my example 2, and I want us to solve this. This is just a fancy way of what we just did. Just a fancier method with some more variables in it. So it's in log notation right now. Can you guys please rewrite this in exponential notation? Same thing we did last slide, just a little more pieces of the puzzle here. Mr. Hayden looks confused just because he wasn't here from the beginning today. See what happens when you miss your live sessions. Okay, so when I change it to exponential notation, what do we start with? 2, right? The little base 2. So I would say 2 raised to the what power? 5. Isn't that always what we do, right? The little 2 raised to the other side. So far, everybody okay? Still exponential notation equals your log. But what's my log this time? 2x plus 8. Even when you guys see more complicated problems, it's the same thing that we just did. That's what I'm trying to show you. There's no different rules. It's still little number raised to the other side equals your log. I can solve this. 2 to the 5th power means 2 times 2 times 2 times 2 times 2, which is that 32? I think so. 32. From here, that's an Algebra 1 problem. Can you guys take a quick minute and solve for x? So on your paper, did we subtract 8? Divide by 2. So what do we get x to be? 12. Good job. So x is 12. Fabulous job. We can check my work. Watch what I'm going to do. You don't need to do this, but you can watch me. I'm just plugging in 12 in place of x. So by the time I'm done, I get log base 2 of 32 equals 5. Let's check myself. Is 2 to the 5th 32? Yes, I did it correctly. See how you can still plug your x back in and check and make sure that it works? So when we were on the last couple slides, we were doing this method. 2 to the 5th equals 32. The same thing. 2 to the 5th equals this whole thing. Do you guys see how it's the same format? Nothing changed, the problem just got longer. Same process, same procedure. Now we did learn one other kind of question last week, which is this one. So let me give you a second. I want you to think about how this one's different than the last one. Who can identify one thing that's different than the last problem? What do you think, Alex?
There are logs on this side.
There's logs on both sides. So we learned last week there's a difference between when we have a log on one side and when we have a log on both sides. So any thoughts on what I need to do here? We learned last week I get to cross these logs out when they match, which is super cool. We love that rule, but I can't cross them off right now. There's these numbers out in front that are in my way. Who remembers what I can do with the numbers that are out in front? Where else am I allowed to write those? Anybody remember the other log rule? It's been a week. We can take it, and where can it go? It can become the exponent. Oh yeah, remember exponents were allowed to move out in front, which means I'm allowed to move them back also. They can go both directions. So I can take this 1/2 and I can also make that an exponent. So let's write my first step. Log base 8 of b to the 3rd power equals log base 8, 64 to the 1/2 power. Now I have log base 8 on both sides. We know in math when something's exactly the same on both sides, I'm allowed to cross that off. That was handy. That was super duper handy. So let's see what we have left now. I have b to the 3rd equals 64 to the 1/2. You're almost done. Our whole goal is to find out what b equals, and we're really, really close. But first I do need to simplify this right-hand side. Do you remember how to do fractional exponents? That was the beginning of Unit 2. The top number becomes the exponent, the bottom number becomes the root. So that's really like saying what's the square root of 64? Okay, so square root of 64 is 8. So top number, exponent, bottom number, root. So b to the 3rd equals 8. So what would b be? What number to the 3rd power is 8? 2. Great job. Great job. Or in other words, to get rid of the cube, you could just cube root both sides and say, what's the cubed root of 8? But most of us are able to, in our head, say, what's the 3rd power is 8? 2 times 2 times 2 is 8. If we plug the 2 back in for b, it would totally work, which is awesome. We love when that happens. So I want to quickly show you how you would check your work, because if you're thinking, I don't know how to check my work on that, that's weird. Let me just show you real fast. So I had 3 log 8, and we found that b was 2, equals 1/2 log 8 of 64. So I would still move these to be the exponent, and watch what's going to happen. Oops, I didn't move that one. So 2 to the 3rd is 8. And 64 to the 1/2 was 8. What did we learn about on the other page? When the log base 8 of 8. What happens when those numbers match? What does this whole thing become? What do we learn on the other page? It becomes a 1. So this becomes 1 equals 1, which, yes, that makes sense. It matches. Which I know you can see from right here. Miss G, they're exactly the same. I get that they're the same. I get that they're equal. But I want us to recognize also that that is a shortcut. When our base matches our number, it becomes a 1. They kind of cross each other off. So those are really your 2 kinds of solving problems. Let's just recap real fast. One is where you only have a log on one side. When you have a log on one side, what do? Change it to an exponent and solve. That one we're really comfortable with because we've done it a whole bunch of times. Our other method is when I have logs on both sides, we're going to put the exponent, we're going to move it as an exponent, cross off your log, and solve from there. So there's really only 2 kinds of solving problems. Does that make you feel a little better? It's only 2 kinds when it asks you to solve. So this week, we get into graphing. Yay, I know you're super excited. Don't hooray or anything. I mean, I know you're excited, but gosh. So logs and exponents are inverses of each other. So the black one is your log function. The blue one is your exponent function. Inverses are where you take this line, which is how your book explains it. It's this line called y equals x, and it just reflects it over that axis, because that's what an inverse is. So multiply and divide are inverses, add, subtract are inverses. logs and exponents are inverses. So we're going to learn some cool things about inverses today. This first graph shows you where b is greater than 1. Now what do they mean when they're talking b? They're talking about this, log base b of x. They're saying if b is greater than 1, that means b could be a 2, b could be a 10, b could be 100, right? When our b is greater than 1, it's going to look like this black line right here. When my b is in between 0 and 1, my line slants the other direction. So what kind of numbers are in between 0 and 1? Can you give me one? Like a 0.5? So basically, if your log is a fraction, then it's going to look like the one on the right. So if you want to make quick notes on your paper here, the one on the left is where your b is greater than 1. So it could be a 2, could be a 10, could be 1,000. I kind of highlighted that portion of the equation for you, where b is greater than 1. The one on the right, when it slants the other way, is when b is a fraction. So we've taken care of when b is greater than 1 and when b is between 0 and 1. Do you notice how there's not a graph for when b is less than 0? What kind of numbers are less than 0, you guys? Negative. Can we do logs of negative numbers? No. That's why it's not included on our chart anywhere, because we've talked about that earlier today. Can't have a log of a negative, because even if your exponent's negative, is your answer going to be negative? No. Your answer turns into a fraction. So you're never going to have a negative b. So what I'm going to do now is I'm going to show you a really cool slide from your online lesson, and then we're going to do this page. So let's do this first. We're going to practice by hand first. You have to appreciate the hard work that goes into it before we have a graphing calculator do it for us. So please find this slide in your notes. It says f of x equals log base 2 of x. And we're going to graph this crazy thing. I've picked numbers for us to try over here on the left, and we're going to see why I picked those numbers in a minute. So remember when we were doing parabolas, we'd always pick numbers right in a row, right? Like -2, -1, 0, 0, 1, 2. With logs, you do not have to pick numbers right in a row. So we'll go over why I picked these numbers in a minute. You get to pick any numbers you want. So the numbers we pick are going to be numbers that are going to work really nicely when I plug it in here. So let's start with 1. I know I'm not starting at the top of my graph. I'll show you why in a minute. So all I did was, this is like an XY table if you want to add that to your top of your table. If my x is 1, I'm going to take the 1 and I'm going to plug it in where I see my x. Everybody okay with me writing it like this? I need to solve that thing. In order for you to solve this, you need to write it in exponential notation. So 2 to the what power equals 1. I'm going to use a little question mark. So what do you guys think? What's my question mark? 2 to the what power equals 1? 0. Good job. I have one coordinate so far, 1, 0. So let's all put that on my graph. I'm going to draw in some really thick lines here for my XY axis. And I'm going to go to 1, 0, and put a dot. I have a coordinate. That was cool. Let's kind of work our way down my graph here. Let's try plugging in 2. So log base 2 of 2. Who remembers the rule? What's my answer when my base matches my big number? 1. If you forgot that rule, can you write it the long way? Sure. 2 raised to the what power equals 2? A 1. So 2, 1 is another coordinate. Let's graph it. At this point, you may be thinking, oh, I know what the graph looks like. It's a straight line. No, logarithms are not straight lines. Can we sort of keep in our head what they look like? They're always like these arched things, right? Like half of a parabola. So let's try 4. So 2 to the what power equals 4? 2. So 4, comma 2 is going to be a coordinate. Are we starting to see it curve a little bit? Okay, good. Let's try an 8. So log base 2 to the 8. So 2 to the what power equals 8. And what do you guys say? 2 to the what power? Not 2 to the 4th. 2 to the 3rd equals 8. So 8 comma 3. Why did I not put a 3? Why did I not choose to try a 3? Why did I choose to not try a 7? Watch what I'm going to do. You don't need to add this to your notes, but just watch. If I tried a 3, I would say 2 to the what power equals 3. Do I know that answer off the top of my head? No, because it's a decimal. I'm only picking ones in the chart that I know are going to give me whole numbers. Does that make sense? If you tried a 3 and you get a decimal, just cross it off for now, because we don't know those off the top of your head. So it's okay if you pick a round value, you just can't plot it right now. Let's try 7. If I said log base 2 for 7, 2 to the what power equals 7, do I know that answer? No, that's also a decimal, so I didn't pick that one. I only picked numbers that I knew I could find the value for. So if you try one out and you're like, ooh, I don't know that one, it's okay, just cross it off and pick a new value. Let's try 0 now. So in your chart, fill this in. So I want to know 2 to the what power equals 0. Is that undefined? Great question. What do you guys think in the room? It's undefined. You can't find that one. We don't know that one. It's not that we don't know that one, it's that it doesn't exist. You can't raise anything to a power and get a 0. So that one would be called undefined. How about at -1? Log base 2, -1. So 2 to the what power equals -1. Can you raise it to the power and get a negative answer? No, not possible. Undefined. So there's a reason that all these values are undefined. The top one will be undefined too, which you'll kind of see a pattern here. Because your graph goes like this. It is never going to cross over that boundary. How did I know it's never going to cross over 0? Because that's the spot where it started becoming undefined. It's never going to cross there. You guys did a good job. Let's try again. Everybody okay? First time is always a little sketchy. Second time always gets a little bit better. Let's try a slightly harder function. We're going to try this one. Don't freak out on me. I think, did I erase the chart on your notes? Did I erase all this side on your notes, or is it all typed in for you? It is typed in? Darn. I meant to erase it. There's no answer there. Yeah, I thought I removed the answer. Okay. So what we're going to do is we're going to try plugging in each of these numbers. And where is it going to get plugged in? For x. I know this looks crazy scary because it's longer, but it's the same thing we just did. So let's do it together. So here I'd have my 2 log base 2. I'm plugging in a -1. I just took my original function, and where the x was, I'm just plugging in my first value, which is the -1. You guys still with me so far? So far we okay? So when I reduce inside my parentheses, I would get -2. I'm going to highlight the part that we need to solve. We just need to solve this log portion first. This is just what we did on the last slide, so let's think about how I can rewrite that in exponential notation. So I'm changing colors here. So it would be 2 to the what power equals -2. You guys okay? Just my highlighted portion, I am writing in exponential notation. What would my highlighted portion become? Does it become a 1? Does it become a 0? What What value is that? 2 to the what power is going to give me a negative 2? It's undefined. So if any part of your problem is undefined, the whole thing becomes undefined for the negative 1. It didn't work. The log portion didn't work because you have to write it out like I did over here on the side. 2 to the what power is negative 2. There's not an answer for it. So at negative 1, I know my graph will be undefined. I won't have a graph there. Can you guys take a second and try 0? I'll write it out with you, but then I want you to try and solve the log portion of it. So take that log portion, rewrite it as an exponent, and tell me what answer you get. So when we rewrote it, did you guys write 2 to the what power equals negative 1? What's that answer? Again, it's undefined. Are we seeing a pattern about my logs? When you're taking the log of a negative, what happens? Undefined. When you're taking log of a negative answer, what's your answer? Undefined. So as you guys get more and more comfortable with it, you no longer have to write it in your exponential format. You know automatically if you see a negative in there with the log, undefined. Okay, so my top 2 coordinates are undefined. I need to clear myself some space. So I'm just going to write undefined, undefined. Let's skip the fraction for a second. Let's come down to 2. Let's try plugging in 2. So I'm working on 2 right now. 2 minus 1 will give me 1 plus 4. I want you to solve just my highlighted portion, and yes, there's an answer this time. What's log base 2 of 1? There's an answer. What do we think is the answer to my highlighted portion? 0. 2 to the what power is a 1? 0. So my highlighted portion is going to become a 0. The 2 is still out in front, the highlighted portion becomes a 0, and then I still have a plus 4 in my equation. So all we're doing, you guys, is we're taking this highlighted portion, we're solving it, and plugging in the value for just that log portion of the problem. So 2 times 0 would give me 0, but my final answer would still be 4. So when I plug in a 2, what answer do I get out of it? 4. So 2 comma 4 is a coordinate. There are a lot of steps going on here, so if you have a highlighter, I recommend highlighting the log portion. That way it becomes a visual for you of what we're really doing. Can you guys try 3? Let me give you a minute to work on plugging in 3, and let's see what you guys get when you plug in 3. So come back to your original. Wherever you see the X, put in a 3. Solve the log portion off to the side and plug in your answer. So what's log base 2 of 2?
-4.
No. Somebody else want to try? It's log base 2 of 2. Taylor? 1. Remember earlier today we talked quite a few times about what happens when your base matches your number? It becomes a 1. Why does it become a 1 though? Because I don't want you just remembering the rule. I want you guys to really understand why. So over here on the side, 2 to the what power equals 2. What will my question mark be? A 1. 2 to the first power is 2. So this whole highlighted section becomes a 1. Does that make sense? Are we okay now? So now when I finish solving this, I'm left with 2 times 1 plus 4, so I would get 6. 3 comma 6 is another coordinate on my graph. So let's draw in my graph and let's see what we have so far. Here we go. So at -1 it was undefined, 0 is undefined, 2 comma 4 was the coordinate, 1, 2, 3, 4, and 3 comma 6 is the coordinate, 6. If we tried the 1/2, we would end up with this, 2 log 2 to the 1/2 plus 4. Anything to the 1/2 power, remember we talked about how do things become fractions? It gets raised to the -1. You guys could try that off to the side and you'd see that that's true. So it would be a -1, which would replace the log section. So we'd get -2 plus 4 equals 2. So 1.5 comma 2. And you would see that your graph goes like this. In order to do these tables, you really have to be able to solve your logarithm problems. How do you solve the log portion? You're going to rewrite it in exponential form and ask yourself what's the answer to that log problem. So you have to be able to take this and write it as 2 to the what power equals 1/2. So you know that your question mark is a -1. You have to be able to go to the exponential form before you can solve your tables. So I love having you guys here with me each week, but once a week for an hour is not enough time for you guys to learn this stuff. You have to be doing your homework. You have to be reading your online lessons. You can't just say, oh, Miss G's going to teach me on Wednesday. I am going to teach you on Wednesday, but it's not enough to make up for a week's worth of material. Do you know what I'm saying? Have to be trying these on your own because homework will go over questions just like this. And what's great is that you guys have access to the answer keys at any time. Do we know where to find our answer keys? We should. It was part of our orientation that you had to turn in to me. So your answer keys for your homework, which are really, really helpful, you can find them under Unit Resources. You may want to add this to your notes. And then you click on Materials. And in there, it's not just the answers. Like if you guys look in the back of the book, it just gives you the answer. If you look here in our online school, it shows you every single step to get to the answer. So you can really say, oh, Miss G, I get the table, but I got stuck on step number 3. Like how did they get step 3? And then I can really help you either through the phone or through K-mail and things like that. But you have to be doing your homework. I can't stress that enough. So there was this really cool thing in your online slides that I want to share with you really fast. So let me start desktop sharing. And this is just so if you want to add this to your notes so you can go back and check it out. This is slide number 4 on lesson 2.10. So what I'm showing you right now is slide number 4 on lesson 2.10. So this is part of what you should have done when you read through lesson 2.10. And what it allows us to do, it's giving us a graphical view of a logarithm function. And I'm going to play around with h and k, and I want you guys to help me decide how does changing h and k change my log function. So look right now in my formula. It's x minus h in parentheses plus k. I'm going to move k first. So this is kind of neat. It's a very interactive tool. So I'm going to take k and I'm going to drag it to the right. So I just made k 2.2. Did we see what happened from my original graph? Let me go back to 0. There's 0. Okay, so here's your original log function. Watch as I make k a positive. Watch what's happening. What's happening to k as I make k positive? It is moving It's moving the graph up. What do we think will happen if I make k negative? It's going to move it down. Can you write that observation on your paper about what k just did to your graph? So when I give you your parent function, and we're just playing around with graphs right now, how many of you guys know your student ID number? Hands up. Okay, because I want to give out iPads next week, but you have to know your ID number and your birthday, which I'm assuming you know, in order to get onto the iPad. So can you guys, if you don't know your student ID, can you email me before next week so I can give it to you so you're ready for the session? Because on the iPads, we could also explore these log functions. So one more time, what's happening with k? As k gets positive, your graph is moving up. As k gets negative, your graph is moving down. Do we understand how k affects my graph? Part of our essential question today. Let's go back to 0. So before I show you, let's make a hypothesis here. Throwing in some science words as Mr. Hayden cuts through my session.
I heard something science.
See, hypothesis. See, I caught his attention.
I got excited. Are we learning about science?
So h. If k moves it up and down, what do we think h might do to my graph? Right and left? That would be a good observation. Let's think about this though. Watch. I'm going to make h positive. Watch what happens to your graph. I don't like the way this is showing you this example. If we look right here on the screen, yeah, I don't like how they're explaining this to you at all. Since h is in parentheses, h is really going to be the opposite of what we plug in. So if I'm making h a negative 2.6, yeah, I don't like how they're showing this to you at all. It's really going to be moving to the right. It's kind of bizarre. It's kind of backwards. And they're not showing this to you properly at all. In our original function, it says x minus. So if h is a positive, let's close out of here. That was not helpful for that. Let's look at what we've learned so far. I will clarify. When I show you this function right here, we just learned about k. K is always the number that's at the very end by itself. So how can you guys, on your paper, can you describe to me what seeing a negative 3 at the end is going to do to your graph? Can you write that down in words next to this slide for me? So automatically, when you guys see a negative 3, what is that going to do to your graph? Okay, now the number inside the parentheses is going to be your left and right, but it's always the opposite of what you see. So if I see a plus 5, normally I would think, plus is to the right. It's not. Here's why. Because your original formula is x minus. So really, your h value is a negative 5. So it's just easier to think of that it's the opposite of what you see. So this would be left 5. The way that I like to think about it and help you guys remember it is, remember when we were doing factors and I would say, here's your factor, what's the solution? The solution is always the what? Opposite. Do you remember that from a couple units ago? So whenever I give you guys something in parentheses, you have to take the opposite of what you're seeing. So if you see a plus 5 here, what does that really mean? That your h is a negative 5. What does negative 5 mean? It means left 5. So parentheses, what should our brains be thinking? Opposite of what we see. We'll talk about that negative in a minute. So let me try one more. I didn't put this one on here, but I'm going to give one to you anyway. If I say log base 8, x minus 3 plus 2. Can you please describe how that graph is going to be shifted from the original parent function? So tell me, what does this plus 2 mean? What does this minus 3 mean? Let's just practice real fast. Because there's a test question that asks it exactly this way. So the plus 2 at the end means it's going to do what? Ooh, what's the number at the end do? It does what it says. So that would be up to. The one that's on the inside is really like it's saying positive 3. And what does positive 3 mean? Which direction is it going to go? Right 3. So you just need to practice those two. K is always at the end, and it does what it says. I like how you put it that way. It does what it says. The one in the parentheses is always opposite of what we see. So if we see a minus 3, that's really a plus 3. What does plus 3 mean? Right 3. It's always the opposite of what we're seeing. Now I have one last one to show you, and that is if I give you the graph, how do you write it back in log form? So last one, if I give you the graph, how do you write it in log form? There's 2 steps, and they're not hard steps. The online lesson really did a good job of explaining these 2 steps to you, I thought. The first is we need to determine your horizontal movement. Horizontal movement means left and right. Everybody okay with that? Left and right. Look at your picture. Your picture shows you your left and right movement. It even gives you a special line to indicate where it moves to. Which line do you think is showing you how far it moved to the left? Where does it show you that number? Anybody want to take a guess? The red one, exactly. The red one is how much it shifted. So how much did your graph shift? -3 spaces. So when I go back to my original problem, here I have log base 6. My formula is x minus plus the k. What's going to be your h value? What number do I plug in? Where did it shift to? -3 spaces.
So it would be like a positive.
Exactly. So when I simplify it, and make sure you do write that step in your notes, that it is a negative at first, because that's the formula, it's going to become a plus 3. Does that make sense? And the answer is yes, because what do we know? When it's in parentheses, what are you really doing? The opposite of what you see. So if you see a plus 3, where are you really moving? Left 3. So it makes sense as far as the formula goes. So now I have my whole formula, but you guys see how I'm still missing one letter. What letter am I missing? I'm missing K. So now I have to go back and solve for K. And the way that we solve for K, it's one more step. I really should put y equals out in front. Are you guys all okay with changing f of x to saying y equals? We okay doing that? Okay. So I have y equals log base 6, x plus 3 plus k. I have 3 variables right now. I have a y, I have an x, I have a k. I'm trying to solve for k. So I need to plug in what an x and a y is. Where in the world could I get an x and a y from? So that way I only have k left in my problem. Any ideas? Where can I get an x and a y from that I can finish solving this problem for k? Do we see one in my picture? Yeah, I see them on the graph. How many x's and y's do they give me? Yeah, they give me 2 x's and 2 y's. So which one am I going to pick? The answer is either one. Whichever one we pick, we're going to get the same answer. So I'm going to do -2, too, just for fun. So let's plug it in. So here would be my x, here would be my y. So my y is 2, log base 6, and my x is -2. We just need to solve. We need to get k by itself. So I'm going to get 2 equals log base 6 of 1 plus k. Everybody with me? I just plugged in an x and y. That's it. I have to solve just like I've been doing all day. I need to solve this log portion. If you need to rewrite it in exponential portion on the side, go ahead and do that. If you remember what the answer is when there's a 1 there, you can go straight to that answer. So rewriting that, I would get 6 to the what power equals 1. What does that log become? 0. Fabulous job. So I get 2 equals 0 plus k. So my k is a what value? K is 2. So we're going to take my equation, which I'll highlight here. Here's my whole equation. And instead of saying plus k at the end, what am I going to change the k to? To a 2. And there's your formula. So that would be my final answer. So when the problem asks me to take my function and write it and basically write the equation for the function, there's 2 steps. Number 1, determine the horizontal movement, which we did from the graph. The line shows it to us. And then step 2, we had to pick a point, plug it in, and solve for k. And then we were done. Yes? We did. We changed the, oh, I see what you're saying. So in order to solve for k, we had to plug in the x and the y. But if they want the equation of the function, they want it back where you have a y and an x in the equation. All we did was we plugged in what my h value was, how did my h change it, and how did my k change it. Yeah, this is normally how they give you a problem when they ask you to graph. This time they didn't give us that. They're asking us to work backwards. So, interesting. Everybody okay with those steps on here? Okay. We actually didn't get to 2.11, which is applications. There's only one application problem on the test. So I'm thinking what I'll do is after today's session, I'll do like a little mini recording on 2.11. There's just one example in here I was going to do with you guys, but this was a lot to sort of digest. So I want you to think about it, practice this, and then I'll have a little mini recording for that very last example. Does that sound okay? Because it's like a lot for our brains to take in that we're trying to do in an hour. Okay, so we're going to skip that last one, which is about bacteria. So I will do a mini recording for that and have that ready for you by the end of the day today, and I'll email you once it's on YouTube. And just a reminder of your essential question, I want to know how does h and k change your graph? You should be able to answer that. So I hope you guys have a great day.